Right, so today I want to talk about physics and electric force equations. So I kind of talked about electric fields earlier, so if I have a negative thing, then the field lines go into it because our test charge is always positive, and then if I have a positive charge, the field lines go away from it. And so if we're going to calculate the strength of this electric field, we use E equals KQ R squared, so the charge of the thing, the K constant, which is 9 times 10 to the ninth, and then our r squared, or how far we are. This could also be d squared too. It just means the distance. And we have this, we call this an inverse square law. So the inverse square, so d to the negative 2. You could also write, and that causes things to drop off very quickly at a distance. So that's one equation we can use to calculate the electric field. But I started by talking about force. So force can be calculated by two things. First, the first force equation is kq1 q2 over, once again, I'm going to write r squared, but it could be d squared as well. And this should be familiar to calculate the force of gravity between two bodies, which is g, gravitational constant, m1, m2 over r squared again. So they have this similar, there are similar forces that work in similar ways, except for charge works in the negative direction. We can't have a negative mass, so this number will never be negative, but these numbers can be negative, the charge, so this is why we have, in gravity, it's only an attractive force, where in electricity, it is an attractive and repulsive force. And then the last equation I want to look at is Fek, which is force equals the electric field times the charge. And we can see where this comes from, right? As far as if we have the charge, F equals K Q1 Q2 over R squared is the same as Fek here, because it's my force is going to equal, if I take this E and substitute K Q over R squared times Q, I get this here. So they're all kind of the same and kind of related. I want to talk about, and yeah, so those are the equations, and that's kind of how they work together.